Hey guys, today we're going to spend our second day on the law of sines. So we're still going to be working with the law of sines. But if you look at the topic today, it's called the ambiguous case for the law of sines. Now, ambiguous means that we're not really certain about something, okay, or like what's going on. And so I'm going to explain this while working through this problem, what this means. Okay, I'll explain what ambiguous means here in a second when it pertains to this picture. But all I'm going to do right now is I'm going to start this problem, and I'll kind of show you what the issue is going to be. So first off, I've got three pieces of information, so I need to find the other three. And I have a match. Okay, I've got big B and I got little b. So I have a match. But the other thing I have is little c. So if I have a match and I have little c, then that means I could try to find big C. Okay, so that's what we're going to be doing on this problem. So let's start with that. So I'm going to do the sine of 40 over 2 equals, and then it's going to be the sine of big C over little c, which is 3. Okay? All right, now, just like before, we're going to cross multiply. Now, if you're trying to solve for c, here's all we really need to do. We need to cross multiply the 3 to the sine of 40, and then just leave that 2 where it's at, and then we'll divide by the 2. Okay, so when you solve a proportion, you usually cross multiply and divide. Well, let's just leave the division part, and technically you could do that first. You could do the sine of 40 divided by 2, and then just cross multiply with the 3. Okay, so that's what I'm going to do. And then I'm going to actually write, the sine of c equals, and then let's do this. So let's make sure my calculator's in the right mode. That would be bad. All right, so we're going to take the sine of 40 times 3, and then divided by 2. All right, so I get 0.964, and I guess we'll call that 2. Okay, I'm going to go out 4 decimals because there's another step we're going to do. We're going to take the inverse sign of that value right there. Okay, so but we've done this before, okay, in solving equations. We need to move the sign to the other side, and that'll be the inverse sign of 0.9642. And now, so now what I need to do is, and I'm just going to leave that exact value in the calculator, not my rounded value. I'm going to leave that exact value, and now I'm going to take the inverse sign of that. All right, so second sine, second, and then I'm going to use my answer button, so it'll plug that exact decimal in, and then equals. And I get 74.62, we'll say. So C equals 74.62. But here's our problem, and here's where the ambiguous part comes into play. If you remember, there are actually, so think of when you're solving an equation, there are actually 2 angles that have a sine value of 0.9642. One of them is over here. That's our 74.62 degree angle. But there's another one over here in quadrant 2 that is like the mirror image of that. It's 74.6 away from being 180 degrees. Okay, both of these angles have a sine value. And if you're trying to solve an equation, or in this case, you're trying to solve for a triangle, we need both of those. So this is one option. 74.62 could be our correct angle, so I'm going to call that C1. But if you take 180 and subtract that 74.62, you will get a 105.38 degree angle that is also an option that could work. So what did I say? 105.38. Okay, there's 2 possible triangles from this. So here's what's happened. if you recall back in geometry, there were ways for you to tell that triangles were congruent to each other. There was like side, side, side. If the three sides of this triangle, three sides of that triangle, then the two triangles are congruent. There's side, angle, side, okay? But there was never, and your teacher always told you, there was no side, side, angle. They usually wrote it as ASS, and they told you that you're not allowed to write bad words or something on your homework. So it's not that it's a bad word, it's that knowing an angle and then knowing the two consecutive sides after that angle is not enough information for what's going on with the triangle. Okay, you could have, so let's say I've got this picture right here. Here's my angle, and then I know this side and I know this side. Okay, I don't really know the length of this side. This is not locked in place. But also this angle's not locked in place. Okay, so there's nothing to tell me that the triangle is positioned like this. It could be that this angle stays put, this side is exactly the same, but then this side is actually going this way. Same side length. This is the same side length because it's the same side, and this angle is still locked in place. This angle up here is going to be different, and this side length down here will be different. Okay, it's either this entire side length or it's this little part of a side that goes from here to here and stops. But both of those are valid triangles that work with the side angle situation that we've been given. So we have to check for both of those. There could very well be two triangles. Okay, so look at what we have. They gave us an angle. We just found another angle. So we can now find the third angle for this possibility. So we're going to call this A1. And so in your calculator, clear, I'm going to take 180. I'm going to subtract the 40 they gave me. I'm going to subtract the 74.62. And I'm going to get 65.38. 65.38. Okay, so that's the angle A possibility of, I believe it's the first situation I gave you. So this bigger possible angle. Or, for that second possibility, we're going to do the same thing. We're going to take 180, we're going to subtract the 40, and then we're going to subtract this angle C possibility, which is 105.38. So if this is the correct angle for the triangle that they were trying to give us, then this would be our angle A, 34.62. Which is like this smaller version. So maybe this original angle was like the 65.38, but when I swing that door shut, I get this 34.62. Okay? And both of these have this bottom side possibility. There's a side A and a side A over here that would work. Now for both of those, we're going to have to use the law of sines. So you can go off to the side, right here maybe. I'm going to start with the numbers they gave us. The sine of 40 over 2, and then the sine of this angle A, 65.38 over A. So plug that in your cross. So this is exactly what we did last class. Cross multiply and divide and figure out A. So 2 times the sine of 65.38 equals, divided by the sine of 40 equals 2.83. So A could be 2.83. So there's the 3 missing pieces of information for this triangle. Or, I'm going to do the exact same thing. Sine of 40 over 2. And now I'm going to do the sine of 34.62 over A. And I'm going to find the possible length of the shorter. Okay, so the 2.83, that's this bigger bottom version. 2 times the sine of 34.62 divided by the sine of 40. And you get 1 point, so we'll call that 1.77. Or A could be 1.77. Okay, so there are two possible triangles, and you've got to find you've got to solve both of them. Okay, so that's what ambiguous means, is that we're not really sure what's going on with this picture. So we've got to find, we don't know which one they're talking about, so we need to find both of them. Okay, all right, take a look at the next one. Okay, so again, they gave us a match, AA, so that's going to be our starting point, sine of 40 over 3. And then they gave us B, so we're going to find big B, sine of B over 2. All right, so same thing. Cross multiply and divide. That'll get us the sine of B. So 2 times sine of 40 divided by 3 is 0.4285. And then we're going to take the inverse of that. Okay, so B will equal the inverse sine of that answer, and we'll get 25.37. All right, so 25.37, but that's just one version. Okay, there's actually another possibility for B. Not only could B be 25.37, okay, which would be like over here somewhere, 25.37, or it could be the angle over here that's in quadrant 2 that also has that exact same, that exact same sine value. Got all caught up in my work and I was off the screen. Okay, so that would be 180 minus the 25.37. So let's do that. So 180 minus 25.37. And that's going to be 154.63. All right, 154.63. All right, so I've got two possibilities. They gave me angle A, I found angle B, so now I could find the angle C that goes with this one. So 180 minus 40 minus 25.37. And that's 114.63. Or I could do 180 minus 40 minus, so now I'm finding this possibility, minus 154.63, and I get negative 14.63. All right, so here's what happened on this one. For this one, there is no second triangle, okay? These two angles together add up to be over 180, and angles in a triangle have to add up to 180. So this could also happen. There isn't a second triangle. Okay, there's only one triangle. We just need to keep going with this, and there's nothing for us to find over here. So that's good. That's helpful. Okay, so we're gonna, and you won't know that until you have to look for it. You have to assume there's a second triangle, and then when you find that these angles go over 180, then you go, oh, okay, there's not a second triangle. We don't have to worry about it. So sine of 40 over 3 equals the sine of, so again, the only thing I don't know is little c. So I'm going to use this big C to find little c. We are going to cross multiply 3 times the sine of 114.63 divided by the sine of 40. And we get 0.64, and I guess just 0.64. That doesn't seem right. All right. Let's try it again. I did something weird on my calculator. You may have seen it. I probably made a mistake. 114.63. And then divided by the sine of 40. All right, 4.24. That makes more sense. Biggest side should be across from the biggest angle, 4.24. So that's it. I have solved that triangle. Okay? Alright, so I'm going to pause the video. I want you to try this last one on your own and see if you can figure out what's going on this one. Okay? Alright, so should have set it up. You've got a match. Big A, little a. So the sine of 70 over 3 equals, they gave us side B, so I tried to find angle B. I cross multiplied like I was supposed to. I got this value over here. Then I took the inverse sine of that value and I got an error message on my calculator. It'll say error, it'll say domain error a lot of times. So here's what's going on. There is no angle that has a sine value bigger than 1. Okay? And the values we got were bigger than 1, and so we're going to get an error message. So what's going on with this picture is this angle, so think about what we've got. We've got an angle, and then we've got the two sides like that are after that angle. So I've got an angle locked in place. It's a 70-degree angle. That's pretty good size. I've got the side next to it. Remember, the A is across from angle A. So if this is the angle I know, this must be the side that's right here. That's 7. And then this side is only 3. It doesn't reach. Okay? There's no way to make a triangle out of this situation. Either the angle's too big or the side's too small. But either way, when you go to solve this, you get an error message. Okay, there is no such triangle, and we're done. There's nothing else to do on that problem except say that there's no triangle that exists. So what can happen with this ambiguous case? Well, you can get two triangles, two legitimate triangles that come from those values. Or you can get one triangle. Okay, the second one doesn't work, it doesn't exist, so we only have to focus on that one triangle and get that answer. Or there's no such triangle that exists from the information that they gave us. Okay, so any of those can happen. That's why this is called the ambiguous case. You always have to assume there is a triangle. If that works, you have to also then assume there's a second triangle. And if that doesn't work, then you don't have to worry about it. And if it does, then you need to find that second triangle. Okay, so take a look at your worksheet. Let me know if you have any questions on this. Thanks.